All right, so let's start with question one, since it wasn't represented in sections, but rather questions. So there's question one, which is carrying 5 questions um, on multiple choice. So we can go through them one by one. So this is question one, and question one is saying a ruler is used to measure the length of an object. What is the length of the object? A ruler is used to measure the length of an object. What is the length of the object? So this is coming from topic one, units and measurements. So if you look at our ruler, the first thing that we're supposed to determine is the scale of the ruler. How is the scale of this ruler oriented? So if they didn't place the object at exactly 0, but rather at some mark um, in the middle of the ruler like that. So the only thing you're supposed to do here is find out the scale of this ruler. So, to say if this is up to here, it's 1, up to here, it's 2. That means this mark, which is here, it's in between 0 here and 1. That means this is 0.5, or this is a half. So that means from here to here, this is 0.5, 1, 1.5, 2, 2.5. So that means our object is starting from 2.5 here. Then we have 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. So since we started from 2.5 and we're ending at 6.5, what are we going to understand? We're just going to subtract those two. So there's not there is no need even to start doing mathematics here. But for the sake, we're just going to say um, our 6.5 here minus 2.5. And this is going to give us how much? It is going to give us 4 centimeters. That means our answer here was B. Question 2 is saying a force F acting at an angle of 60 degrees to the horizontal has a horizontal component of 8.5 newtons. What is the magnitude of this force? What is the magnitude of this force? So they've already given us the horizontal component, the x component of this force F, this guy here, and they've given us to say the horizontal component is this one, which means that is our x component, and the angle, the direction from the positive x-axis, that is 60 degrees. So they're asking us to find the magnitude of this force F. So what are we going to take note of? We're going to say theta of this force. Let me just change the color of my pen here. Okay. So theta of this force is equal to what? It's equal to 60 degrees. What else do we have? We have the x component of this force to be 8.5 newtons like that. So when dealing with projectile motion or vectors, we know to say for you to find the x component, what do? We'll say the x component is equal to the force F, which is the magnitude of this force, cosine theta, of which our theta here is 60 degrees like that. So we've already been given this x component to say it's 8.5. So what are we going to do? We're just going to replace that guy here. So we have 8.5. This will be equal to what? It will be equal to F cos 60 degrees like that. So I'll divide both sides by cos 60 degrees, even this side by cos 60 degrees, and this is going to give me what? It is going to give me, this guy will cancel out. F will be equal to 8.5 over cos 60 degrees. This is cos, sorry. This is cos 60 degrees. So if I divide those guys, 8.5 divided by cos 60 degrees, I'm going to get my F being equal to, let me just punch on my calculator, 8.5 divided by cos 60. Okay, 8.5 divided by cos 60. I'm getting an a value of 17 newtons exactly. So which means the value of our F is 17 newtons. And if we go back to our multiple choice, we're going to find that our correct option here is the option B. Okay, that was question 2. Question 3 is saying a car travels along a straight road. The speed time, I guess they were supposed to complete it to say the speed time graph. The speed time graph for this journey is shown, during which labeled part of the journey is the resultant on the car 0. So they want us to give an option under these that have been shown on the distance time graph here, or the speed time graph rather. They want us to show them which part is having a resultant force equal to 0 on the car. And for our resultant force acting on an object to be equal to 0, that means all the forces on that object are balanced. The forces on the left are equal to the forces on the right. The forces acting down are equal to the forces acting up. And I remember very well when I was teaching Newton's laws of motion, I explained to say summation of forces or summation of forces on an object can be equal to 0 if there is no acceleration. Because if we're using Newton's second law of motion, we say summation of forces is equal to what? Is equal to mass multiplied by acceleration. But if there is no acceleration, that means this whole side, the right-hand side of our equation, is going to be equal to 0. And what does that mean? What does it mean when acceleration on an object is equal to 0? That means there is constant velocity. There is no change in velocity. The velocity is the same. So our job is to find the part on this speed time graph where the velocity is not changing. The velocity is constant. That means the forces on this car at during that point in time, they were balanced. And which labeled part is that? We can see to say the only straight horizontal line which is depicting constant velocity is this guy which is here, B. And that's going to make us conclude to say the time when the forces on this car were balanced was when the velocity was constant, which is option B there. All right, so that is question 3. We can now move to question 4. The figure below shows a stationary metal block hanging from the middle of a stretched wire, which is suspended from a horizontal beam. The tension in each half of the wire is 15 newtons. The question is, calculate the weight of the metal block. Calculate the weight of the metal block. So what are we going to do in order for us to find the weight of this metal block? We're going to draw the resolved forces on this graph. We have tensions. This is the metal block they're talking about. We have tension on this side and tension on that other side. So since this tension is at an angle, we can tell to say it is existing in both axes, both the X and the Y axis. So what am I going to do? That means this tension which is here on the right, there is tension pointing in that direction. And since it is since this is 20, that means even that angle there is 20, like that. So since this is adjacent to the 20 degrees, it is going to carry a cosine. So it will be 15 cos 20. And another one is going to point up there. And this, since it is opposite to the 20 here, we're going to say it is carrying a sine. So it will be 15 sine 20. Sine 20 degrees like that. Even this other one, which is also here, it is pointing in that direction. And since it is also adjacent to this 20, it is going to carry a cosine. So I'll say 15 cos 20 here. And we also have another one pointing up here. And this, since it's also opposite to the angle theta, this is also going to carry a sine. So it will be 15 here, sine 20. So you can see now to say we've resolved our forces. We have forces in the x-axis and forces in the y-axis. And since the weight of this block is in the y-axis, for now, we can concentrate only on the forces that are in the y-axis. So how are we going to do that? We have 15 sine 20 and 15 sine 20, pointing in the positive direction of the y-axis. Since we know today the positive numbers in the y-axis are above 0, that means those are positive, whilst the weight is pointing down, so we'll consider it as a negative force. So I'll go to my diagram here, or my board rather, and I'll say question 4. This is question 4. Question 4. I'll say summation of forces in the y are equal to 0. And what forces do we have in the y? We have 15 sine 20 plus 15 sine 20 minus m, which is the mass of that object. I've said it's pointing down, so I'll consider it as a 0. This will be equal to what? This will be equal to 0, like that. Okay, so I'm going to take this mass, which is negative, to the other side of the equation. I'll 15 sine 20 plus 15 sine 20 being equal to m, which is the mass of this object. So m will be equal to, what is the value of 15 sine 20? That is 5.13 plus 5.13. And finally, we'll get our m is equal to what? It is equal to 10.26. And that is the value of the weight of our m here. So if that is the answer, we found 10.26 newtons. So it has been what do you say? I've forgotten the term. Yes, they've put the answer correct to 1 decimal place. And if you put it correct to 1 decimal place, 10.26 is the same as 10.3 newtons. That is giving us the weight of our block M. Okay, question 5. A box of mass 8 kilograms rests on a horizontal rough surface. A string attached to the box passes over a smooth pulley and supports a 2 kilogram mass at its other end. So we have a box of 8 kilograms here lying on a rough surface. Then we have another box of 2 kilograms lying on the other surface there. So when the box is released, a friction of 6.0 newtons acts on it. What is the acceleration of the box? Okay, so let's draw our free body diagram. My board here. This is question 5. What have I done? What have I done? Okay, let me just... Okay, so my diagram here, I put question 5. Then we have this diagram. There is one block resting on a rough surface, and there is a pulley passing through there. Then there is a 2 kilogram block there. So here we have forces, mg acting down there, and tension in the string. Here we have tension in the string pointing in that direction, and we have mg pointing down. Since it's on a surface, we have normal force pointing up there. Then we have frictional force acting in the opposite direction here. So there's tension here, tension there. So what are we going to do? We have to find the acceleration of this block. So if I look at this diagram, which is on top, lying on a surface there, we're going to find out that reduce it, okay, like this. So we're going to find out that summation of forces in the x-axis will be equal to what? Will be equal to mass multiplied by acceleration. And what forces do we have in the x? We have friction here and tension pointing there. So I'm going to say tension minus friction. This will be equal to what? This will be equal to mass. Mass of which one? Mass of the block that is that is on top of the table. And what is the mass? It is 8 kilograms. So 8, which is mass multiplied by acceleration, A, like that. That is the forces on that object. And we've been given to say when they are released, a frictional force of 6 newtons is produced. So let's replace this guy here with 6. So I'm going to say T minus 6.0. This will be equal to 8A. Like that. This object, which is suspended freely on a string, we have forces in the y-axis only. And which forces do we have? Well, this force, which is acting towards the direction of acceleration, so it is positive, and tension, which is acting opposite to the direction of acceleration, which means tension is negative here. So I'm going to say my mg, and what is the mass? The mass is O multiplied by gravity, which is 9.81, minus tension. This will be equal to what? Mass times the acceleration. What is the mass times acceleration? The mass is 2 multiplied by A, like that. So those are the forces that I have. If I multiply these guys here, I'm going to get 19.6 minus T being equal to what? Being equal to 2A, like that. Okay, so now I can make T the subject of the formula in this equation here. Why? I'm going to transfer negative 6 to the other side of the equation. What am I going to have? I'm going to have T is equal to 8A minus 6.0. Then since this is T, I'm going to replace it into this equation here. So I'm going to get 19.6 minus, what is our T? Our T is 8A minus 6.0. I'll put this in brackets. Oh, it's plus. 6.0 here was a negative, so if I take it to the other side, it will be a plus, like that. All right, so there'll be a plus here, and this will be equal to what? This will be equal to 2A, like that. So if I distribute the negative into the brackets, I'm getting 19.6 minus 8A minus 6.0. This will be equal to 2A, like this. I'm getting negative 8A and take it to the other side, it will be plus 8A, which means I'm remaining with the 10A. If I add 8 plus 2, I'm getting 10. So 10A will be equal to 19.6 minus 6 here, which is going to give me what? 19.6 minus 6. I'm getting I'm getting 13.6 divided by 10, even here, divided by 10. Cancel out the 10 there. I'm remaining with A, which is the acceleration, being equal to 1.36 meters per second squared. So that is the acceleration of this object here. And which answer is that? 1.36. Okay, so it has also been put to 1 decimal place. So it is this guy here, which is option A. So that was question 1, the whole lot of question 1, which is comprising of five multiple choice questions. And we are done with it. We can now proceed to question 2.